This is a video on finding the empirical formula from experimental data. Basically what we're going to do is we're going to get a sample of ethanol in an attempt to try to figure out what its empirical formula is. We're going to start out with a sample size of 11.5 grams. We're going to take that 11.5 grams of ethanol and we're going to burn it. In other words, we're going to take that ethanol, and react it with oxygen, and it's going to form carbon dioxide in the gaseous form and water also in the gaseous form. Now we're going to do this in a special device which will basically capture the carbon dioxide and the water in separate absorbers. So there's an absorber for the carbon dioxide, there's an absorber for the water, and it's going to capture the carbon dioxide and water that are produced from the ethanol reacting with the oxygen. Now ethanol contains carbon, hydrogen, and oxygen. And what we're going to do in this experimental method is figure out how many grams of carbon, hydrogen, and oxygen are in the original 11.5 grams of ethanol. Once we figure out how much of each of those is in the original ethanol, we can determine the empirical formula of ethanol. So let's get rid of all this stuff and let's move on. So how do we go about doing this? Well, if we recall, carbon dioxide has a molar mass of 44 grams per mole. Now of those 44 grams total, 12 grams of that is actually carbon. So there's 12 grams of carbon for every 44 grams of carbon dioxide. Now basically this is the percentage of carbon in carbon dioxide. That's what it turns out to be. Hang on one second. There we go. When the 11.5 grams of ethanol burns, it turns out that it produces 22.0 grams of carbon dioxide. Well, my friends, this is the carbon dioxide that's produced from burning the ethanol, and obviously it contains the carbon that was originally in the ethanol. So if I take the 22 grams of carbon dioxide and literally multiply it times that percentage of carbon which we showed you before, which is 12 grams of carbon per every 44 grams of carbon dioxide, we can figure out how many grams of carbon is in the original ethanol sample. And it turns out 22 times 12 divided by 44 is 6 grams of carbon. So we now know in the original ethanol sample that there are 6 grams of carbon. Alright, we're going to get rid of that. Go back to writing. So we know there's 6 grams of carbon. Remember, we've got some water produced too. In fact, it turns out that 13.5 grams of water are produced when that 11.5 grams of ethanol burns. We can figure out how much hydrogen is in the original sample, because this hydrogen here in the water is from the original sample of ethanol, which remember contains carbon, hydrogen, and oxygen. So we can find out by doing the same type of thing. We know that the molar mass of water is 18 grams of water per mole. Right? So, of the 18 grams, 2 grams of that is hydrogen per 18 grams. If that's the case, that's the percentage of hydrogen in 1 mole of water. So, let's do the same thing now. Let's take the 13.5 grams of water and multiply it times 2 grams of hydrogen per every 18 grams of water. When we do that, it turns out that 1.5 grams of hydrogen is produced. So, we've got the number of grams of hydrogen, and from the previous calculation, we've got the number of grams of carbon. What we don't know is how many grams of oxygen. Now, that's a bit of a problem because of the fact that not only is there oxygen in the sample, the ethanol, because remember, it contains carbon, hydrogen, and oxygen, but we also added oxygen to it when it burned. So the oxygen that we have, well, we're not exactly sure whether it comes from the ethanol or the oxygen that burned. And when I mean the oxygen that we have, I mean the oxygen that's in the water, the oxygen that's in the carbon dioxide. So we can't use a percentage method to try to, just like we did, find out how much hydrogen and how much carbon. We can't use a percentage method to figure out the amount of oxygen, because some of the oxygen comes from the oxygen in the ethanol, and some of it comes from the oxygen when it burned. But there is a really simple method of figuring out how much oxygen we have in the original sample. Well, if you recall, 11.5 grams of ethanol is what we started with. I'm just going to abbreviate it as Eth. If we subtract from that the mass of the carbon plus the mass of the hydrogen, we should get the mass of the oxygen in the original sample, which in this case turns out to be 4 grams of oxygen. So now we know the mass of the oxygen, the mass of the carbon, and the mass of the hydrogen. We know all three. So now we can use those to find the empirical formula very simply. Alright, so let's do that next. Okay, so we're going to take the 6 grams of carbon. We've got the 1.5 grams of hydrogen. And we've got the 4 grams of oxygen. And we're going to convert each one of those to moles by very simply dividing them by their molar mass. 12.01 grams of carbon per mole, 1.01 grams of hydrogen per mole, and 16.00 grams of oxygen per mole. Oop, that's an O. Sorry about that. So 6 divided by 12 is obviously 0.5. 1.5 divided by 1.1 is 1.01 is about 1.5. And 4 divided by 16 is 0.25. So it's a ratio of 0.5 moles of carbon to 1.5 moles of hydrogen to 0.25 moles of oxygen. Which, of course, we want to simplify that because we know the subscripts cannot be fractions. They have to be whole numbers. So we're going to divide each by the smallest of the 3. And obviously this is a 2. This turns out to be a 6. And this turns out to be a 1. So the whole number ratio of carbon to hydrogen and oxygen is 6 to 2 to 1. Which must mean that the empirical formula of our ethanol is almost. Came really close. Almost said 6. C2H6O. And this is how we find the empirical formula from experimental methods. Okay. If you have any questions, see me or Mr. Walsh, and we'll talk to you tomorrow. Bye.